So there's always a little bit of a nuance when it comes to word problems, right? Okay. As with all previous functions, we will be able to perform sinusoidal regressions. Remember, you need 5 points, and I told you already why, right? That's kind of like a full cycle. If you jump between max, mid, min, back to the max. But in the fact is you don't need those 5. Any 5 will do within a cycle, right? Within a cycle. If you're outside the cycle, then it's not going to work for you. Type A, you will be provided with points, right? So that's what we're going to do today. Provided with points. Just enter, determine the equation, answer as needed. Type B, you will need to determine the point yourself. So starting tomorrow, I'm going to focus on that. Okay? Starting tomorrow, I will focus on that. So type A, Mr. is going off-roading with his Jeep. He gets to a point on the road where there's 1 foot of water sitting there. The height of a certain point on one of the tires with respect to the water surface has been recorded on the table below, right? And I will highlight this. The height of the tires with respect to the water. With respect to the water is kind of like your ground in this case, right? It's kind of like 0. This is page 21. Yeah. And here we go. Time in seconds, height in feet. So we know what to do there. L1, L2. But please tell yourself that this is time, X is time, and your Y is height. Especially with logarithmic. Remember, logarithmic is the one tricky one where time is often your Y variable. Okay. Determine the sinusoidal equation that would model the height in relation to time. So, right, stat, calc, sine, reg. Okay, just do that. That's all you need to do. You don't need to give me L1, L2, any of that, because you're already telling me that up here on the chart itself. So let's just come up with our quadratic sinusoidal. Stat, edit, and you know what to do. This is what I get. Before I write it down, do I have a few nods? Is that what you're getting? Yeah. 3 point, and then we're gonna go 2 decimals is fine along the way. But for this, for B, you already know the drill, right? 14859. I'm gonna go 5 decimals. More is better. 1.53 plus 1.92. Promise it's a 9. Bingo, we got it. How long does it take for the tire to complete a full revolution? Find the period, right? That's what it's asking for. We're going to go 2 pi divided by 3.14859. and that would be 2, right, rounded. To what? We are in seconds, right? It takes 2 seconds for that to happen. That's it. What is the lowest and highest point the tire achieves? Explain what the negative value represents. So Y max would be, you can use your calculator, of course, to figure this out, right? And Y min is the lowest, 1.92 minus 3.03. You know you're going to get a negative there. .95 feet, and then that's a negative 1.11 feet. That's the lowest. So I'm just going to make sure, right? Highest, lowest. Highest, lowest. So the negative value, right? It means that the tire, right? The point on the tire, is 1.11 feet below the water surface. Below the water surface. If Mr. I forgot the Mr. D. If Mr. drives 60 kilometers an hour and the flooded part is 200 meters long, right? So at this speed going through a stretch that's 200 meters, right? How many revolutions will the tires make? So how would you approach this one? What do you need to know in the first place? Convert. We're going to have to figure out how long would it take at this speed to go through there. We know that every 2 seconds, right? Every 2 seconds, there's one revolution, right? So we find out, right? Determine time to go through 200-meter stretch. Okay. So we're going to figure out that. So various ways of doing that. I'm going to turn this to meters per second. Okay? You remember how to do that? Right? That's what that is. I know that 1 kilometer has 1,000 meters. And I know that 1 hour has how many seconds? 3,600. So kilometers go with kilometers. This hour here will go with that hour there. And so all you have left is meters and seconds, right? So let's figure that out. So it's 60 times 1,000. That is 60, and then just add 3 zeros, right? Over 3,600 seconds. And we can turn that. How do you want to do this? There's various ways. You can just divide them and get a decimal. You can also just say, hey, I'm just going to cancel the trailing zeros. So that's really 600 meters in 36 seconds. This is the speed when if you were to say it in meters per second, and we could turn it to how many meters in 1 second. I'm just going to leave it like that. Okay, this is the speed, right, of Mr. Dirkson's car. So I'm going to use this now, saying, hey, cut it here. If it's 600 meters in 36 seconds, how long would it take to travel 200 meters, right? How many seconds would that be? And I'm going to just answer it here. It's 200 times 36 divided by 600, right? 200 times 36 divided by 600. That is 12. You can, we knew that already. I don't even know why, right? We knew that, right? This times 3 gets you there. So 12 times 3 would give you 36, right? You should see that pattern. But it takes 12 seconds to go through 200 meters. So we need to figure out revolutions, right? Revolutions would be 12 seconds divided by 2 seconds, 6 revolutions. Whoa, right? That's a lot of work. Well, this is a review from design and measurement. That's why I wanted it in there, converting, right? Units are fairly standard here, nothing that you didn't already know. And then I use proportional reasoning, say, hey, if this is true, then how long would it take? It would take 12 seconds. And then the last step is to use the period, right? And just divide them and get your number of revolutions. So because it's so easy to get the equation, I can step it up a notch on the other questions. What else could I have asked? Are there more questions? I always forget. No, there are no more questions. So I could have asked how long does the tire stay at or above, 1 foot above the water. I could have asked that. The same questions as before. Nothing really changes here. Let me see here. I think there's a graph on page 22, right? Go to page 22 there. And that'll be it for today. Maybe I will already give you the homework. Let me just scan through. So this is actually a bigger worksheet that I'm going to assign. So you go through, it goes from page 26 all the way to 32. So at the top of page 22, page 26, but I'm going to narrow it down because some of you don't have that kind of time. I want you to at least try the regression questions, right? So I'm going to tell you which ones I would strongly suggest. So question 2 and question 6, okay? Must do question 2 and question 6, and the key will be posted to everything from page 26 to 32. There's basically one question per page, but then just focus in. It starts at question 1, 2, 3, and so forth. Just focus on these ones. They have regressions as part of it. Before I do this stint here. So this is also something you need to be able to do, compare two graphs, right? So Alexis and Colin own a car and a pickup. They noticed that the odometers of the two vehicles give different values for the same distance. As part of their investigation into the cause, they put a chalk mark on the outer edge of the tire. The following graph shows the height of the tires as they rotated the vehicle at the same slow constant speed. What can you determine about the characteristics, if you want to highlight that, characteristics of the tires from these graphs, right? So we're going to talk about the main characteristics. So on the side here, amplitude. What is the amplitude when it comes to wheels again? What does that tell us? The amplitude tells us the length of the tire, not the circumference. It can give us the height, but it actually gives us the radius. The amplitude is just the radius. 2 times the amplitude would be the height of the tire, or the diameter. Right? So amplitude is the radius. Right? What's the amplitude for this one right here? Let's go A is equal to, there's a min there and a max there, which is 24, right? Let's label this one. This is 1.224. And this one here is 0.60, right? So obviously we would just go max minus min. It's a little irrelevant, right? So it's 12 inches is the radius of the car, right? And we obviously expect, you can see that the amplitude of the truck will be greater, right? And that makes sense because it's a bigger tire. So we're going to go, what's the highest here? 32 at 1.6, 32. And this is just 0 here, right? So it's 32 minus 0, so max minus min divided by 2. And that is 16 inches. A truck has bigger tires, So having a greater radius, amplitude, right, makes sense, right? So we just compare that. Right? Next, we're going to talk about the midline. That is given to us by D, right? In the equation, that would be D. And for the midline for this truck, or for this car, sorry, would be max plus min divided by 2. And so that's 12. Also 12 inches. Midline for the truck would be 32. So max plus min divided by 2 is also 16 inches. And I'm just going to use a highlighter here. I'm just going to say that, right? The midline is 12 here. And it is 16, okay, for the truck. It tells us a bunch of things. It tells us that, right, the center of the tire is higher off the ground for the truck. And that also makes sense because it has a, right, like it's just a bigger tire. It would make sense that, right, this is the car, truck is higher off the ground, and so that'd be the midline. The other one would be the period. Those are the main characteristics of a tire, of a sinusoidal function. These are very important to us. Yes, you can talk about the max and the min as well, but just be ready to explain what they mean, right? So period, that would be, in this case, x max 2 minus x max 1. And it's like, isn't it 2 pi divided by b? We don't know what b is, right? We don't have a function, we don't have the equation, so we just go with this, right? So let's figure out the period for this one and for this one. Question, which one is going to have a shorter period? which one of the tires can you predict will have a shorter period, will complete a full rotation faster? The car, right? That's we kind of know that already. If you approach questions like that, you can actually predict or make fewer mistakes, right? Because you're expecting that. So this would be 2.4, 24. That's my other max here, and I'm gonna go. I have a problem here. Oh, there's another max right there. Okay, no, I'm good. Otherwise, you would have had to use the min and the max and then times it by 2 or get the 2 mins here to get your period, but that's okay. This is 0.32. So the period here is easy for this one already. It'll be 1.6 minus 0. That's just 1.6, and this is in seconds. For the car, it's 2.4 minus 1.2, and that is 1.2 seconds. The tire of the car completes a full revolution in less time compared to the truck. That also makes sense because it's a smaller tire, takes less. That's why, this is just an aside, if you ever get a truck and you beef up your tires, like you get bigger tires, you need to adjust your odometer. Like they have to actually go into the computer and change, because the tire, the diameter of your tire is programmed into the computer. And now if you beef it up, you're actually going faster than what you think, right? You're actually sometimes even 10 kilometers an hour faster. So people get tickets. So I was going 60, right? Well, did you upgrade your tires? If you did and you didn't change, so you either need to know that you just need to go slower, or you need to get that fixed on the computer of your car, right? I think it's called the ECM or something like that. Anybody mechanically inclined in here?